In large part because of your involvement, whether through advocacy, research, or dedicated work, U of M has established aggressive carbon neutrality goals with an emphasis on instilling sustainability throughout campus life and with environmental justice being central to our approach. Before we get started, I want to quickly reiterate some of our climate commitments. Last spring, U of M pledged to eliminate without offsets all greenhouse gas emissions from direct on-campus sources by 2040, achieve net zero emissions from purchase power by 2025, and by 2025, establish carbon neutrality goals for other indirect emissions sources, such as commuting, university travel, and purchased goods. Countless people throughout the institution are playing a role in moving us toward these goals. We are already making great strides, which you can always track at planetblue.umich.edu. Today's webinar focuses on campus buildings, which are overwhelmingly the largest contributor to direct on-campus emissions, known as Scope 1, as well as on our demand for purchased electricity. It's important to point out that today's discussion is focused on building level interventions and will not get into district level solutions, such as geothermal exchange, which are a significant part of the university's overall approach to pursuing carbon neutrality. Today's panelists bring a wealth of knowledge and experience. They were all directly involved with building level analyses conducted for the President's Commission on Carbon Neutrality and have continued to move the work forward toward implementation. So it's my pleasure to introduce Lars Jungens, is an associate professor at Taubman College of Architecture and Urban Planning, where he focuses on developing holistic, optimal solutions for the challenges of buildings in different climate zones. Prior to coming to U of M, he worked on the realization of award-winning net zero emission buildings. Lars co-led the President's Commission on Carbon Neutrality internal analysis team on building standards. Since then, Lars has been advising the development of new building standards that reduce life cycle emissions. Jen McGray is a licensed architect and an associate professor at Taubman College of Architecture and Urban Planning, where she specializes in sustainability and architectural design. Jen co-led the building standards analysis team alongside Lars and continues to advise on implementation of the team's recommendations related to performance standards by building type. Kevin Morgan is the manager of U of M's energy management team and a graduate of Taubman College of Architecture. The team uses technology and engineering skills to make campus buildings more energy efficient. Kevin brings 18 years of expertise to bear on U of M's commitment to increase building energy efficiency, in part through the recently launched REVOLVING Energy Fund, which creates a sustainable funding cycle for energy conservation projects. Marina Roelofs has served as the Executive Director for Architecture, Engineering, and Construction since 2000. The department is responsible for the design and construction of all capital projects at the Ann Arbor, Dearborn, and Flint campuses. Marina is currently leading the effort to develop new building standards, including maximum carbon emissions targets for new construction and renovation projects by building type. Thank you all for joining us today, and thank you in advance for sharing your expertise and perspective. Before we begin, I'd like to welcome anyone in the audience to feel free to submit questions during the presentation, as we will do a Q&A right after. You can also feel free during the event or at any time thereafter to submit a comment to the public comment portal at planetblue.umich.edu/carbon neutrality. And now we will begin our presentation by discussing building standards.
Good morning, everyone. I'll get us started by just mentioning that the building standards work that Lars and I co-led was also supported in large part through work of a group of student research assistants whose names you see here. So as a collective team, our scope and our charge was to really be considering the standards as related to new construction. You can see the next slide. As Katrina already laid out, buildings contribute a very significant portion of the Scope 1 and 2 emissions. And so for the building standards, we were asked to evaluate and to put forward building standards specifically focused on new construction and major renovation through the lens of building type. We already knew moving into the work that building type is one of the strongest influencers of performance related to the kinds of activities and the kinds of energy demands already in place with the variety of buildings that we find throughout the U of M campuses, Ann Arbor, Flint, and Dearborn. Next slide. This context was also within existing performance standards. U of M was already performing better than state standards require, with a 30% stretch beyond the ASHRAE 90.1 2013, which is the current standard adopted. And we also know that ASHRAE standards are moving towards net zero, but with a goal of getting there around 2030, also dependent on whether states adopt those goals. And U of M has a desire to move there more quickly, so the building standards was looking for efforts to get there faster than code otherwise would. Next slide.
Yeah, the next slide is on my side. At first, I was very happy to be involved in the project to try to find solutions to reduce the CO2 emission for the UM campus. And here I was involved in projects before with buildings, university buildings, which have been net zero or even below. And I'm also currently working on projects here in Michigan to design a net zero building for my own purpose. So please go to the next slide. And what I want to present right here is a little bit the technical background which we worked on. Since I told you that I worked on these kind of projects before I came to University of Michigan, what I have learned is that we have to look not just at the building itself, but at all of the energy flow which are going to provide the energy for our building operation. So to look at the CO2 emission, we just have to look not just at the building itself, but how the energy is produced or how the energy is generated. This means how the electricity is generated. Yeah, this is very important to make an evaluation of the CO2 emission of buildings for its building operation. The next slide, please. So we have had the approach to develop a standard which is not just based on the energy demand, but which is also based on the CO2 emission and probably also at the cost. So how much does it cost to have a building which produces less CO2 emission? So, and we are not the first one doing it, but there is an international standard, which is called the 18599 standard, which was developed in Germany and is now in the European Union, a kind of general standard for buildings, which is not just based on CO2, but is also integrating the cost of the building. Here you can see an example building from the United Kingdom, which is using this kind of standard. You now these kind of evaluations, when you are going to buy a fridge, for example, A means it has a relatively low CO2 emission, and so on. You know, and according to these, we developed also a kind of CO2 emission standard for buildings for the UM campus. Please go to the next slide. All the technical calculation is based on a small set of international building standards, which are focused to calculate the CO2 emission and operation cost. This is a kind of very intensive work, which is specialized on all types of buildings. the residential buildings, office buildings, university buildings, hospitals, everything. And it also includes not just the heating and cooling, but also the energy which you need for the duct design, for the lighting, for water heating. So it's a very comprehensive international building code, which we have used. While the building code was focused on European climates, what we did in our work is to transform this standard to our local conditions with more dehumidification, per example, to our local conditions here in Ann Arbor. Please go to the next slide. And we did a lot of building simulations. So we have used these building code and we have used dynamic simulation tools. And then we tried to find the optimal situation. The optimal situation, not just to reduce the CO2 emission, but also to find a cost-effective solution. So here in this diagram, this example, you can see, there are different points where you can see for the CO2 emission reduction and for the cost, for the operation cost reduction. And the optimal point is that one which is closest to the 0 point. So we tried to find, we combined different options to each other. And we tried different things like better lighting and more insulation and so on to find the best solution for the best optimal cost for it. So we did a lot of building simulations to find an optimal spot, and then we made recommendations for different building types. So please go to the next slide. And then we made some recommendations for different building types. Here you can see this is also part of my research work, which is talking to find optimal solutions for building renovation in the residential area. Also here looking not just for the CO2 emission, but also for the cost. How much does it cost? Always to find a kind of optimal solution for both aspects, cost and CO2 emission. Next slide, please. And finally, we made a recommendation for a specific CO2 emission, a specific per square foot building area, to find a kind of CO2 emission, which we found to be as most appropriate. So it's not the smallest CO2 emission which we can achieve, but the most cost-effective CO2 emission. So we made a kind of classification for different building types to find optimal solutions. And then we made a kind of guideline how we can achieve this relatively low CO2 emission per square foot building area. Next slide, please. And these are a little bit recommendations which we are going to give. It's very important that we are going to see the approach as a general holistic approach, not just to think about the building envelope or the HVAC systems. So we need to see all these different aspects, building physics, building materials, HVAC systems, and even to go to the energy producer and renewable energy sources on the building site. So it's best to find a holistic solution for these problems which we are going to target. Thank you very much.
Thank you, Lars. That was a great introduction. So after the president announced the plans to begin implementing many of the recommendations, work streams, teams were created for the different PCCN recommendations, and ours was charged with incorporating the maximum greenhouse gas emission targets for the buildings. Next slide, please. Our workstream membership consists of technical folks from our department, AEC, the Office of Campus Sustainability, the Provost Office, Student Life, Michigan Medicine, Athletics, and U of M Flint and Dearborn. In addition to, plus we have input from the PCCN and special advisors and the PCCN analyst teams as shown on this slide. Next. So as Jen and Lars covered, the PCCN building team created these maximum emission targets for these building types. And the targets are represented in two ways, a total number and also a reduction to the ASHRAE baseline as indicated in the chart here. As the work stream started looking at these, we determined that to incorporate these into our building standards, it would be beneficial for us to add more definitions to assist our project teams in determining which building categories or categories an individual projects would fit into, because most of our buildings have several space types within the same buildings. Just as an example, if we look at the biological science building completed a couple of years ago, it has a few different building types in one building. Next. Therefore, our efforts to date have been to look at the building types and add space types and infrastructure needed for the activities within the buildings. And as we worked on these added definitions, we also looked at whether there were building types that needed expansion or refinement. As I already covered, we have done this in collaboration with faculty experts, university units, and our technical staff. And we are now working on a new design standard to add these maximum emission targets in all of our designs. Next. This slide represents and is an example of the additional definitions to the building types that I've been working on. This is for the educational, no lab, low lab, and high load lab. And they were the buildings that were at the beginning of the chart that Lars and I just showed at the previous charts. And what's in red is what we are adding in a summary fashion. To assist in the understanding of the buildings, we added these three categories for each of the building types: the definition, a space type, and infrastructure. And in the infrastructure, in this example, you can see that within these educational buildings, the major difference is in the HVAC, ventilation and exhaust, and the plug and process load that drive the greenhouse gas. This information will assist our teams in creating the most stringent greenhouse gas target versus trying to fit a building into one category just based on the largest space use. Like back at the example of BSB, it would be difficult to fit all into one building type. If we did that, we primarily have wet labs, and therefore that would be a very high, will fit under the high load lab, and it would not really represent the use of the total use of the building. And because we have wet labs, but we also have exhibition spaces, classroom, and museum space. So we want to adopt the most stringent greenhouse gas target, and that is how we want to move forward with our standard. Next. Then we also looked at how do we address building types that are not covered, like dining halls, storage buildings, et cetera. And for these, we also think that the space use and infrastructure needs and the % reduction to the baseline ASHRAE will help us arrive at a target for those type of buildings also. Next. So our next steps are to finalize these definitions and the new building standards for incorporating the targets into our designs. Then we would submit our recommendations to the university leadership and expand the work to renovations and continue working on improving the reduction measures on our project. And as a note, we are utilizing these targets currently in our current design as we work toward incorporating them into our standard. So now I'll turn it over to Kevin Morgan to cover the efforts in energy management.
Thank you, Marina. Good morning, everyone. So to talk about emissions reductions, I want to start with a summary of the work that our team is doing right now in campus buildings, and then work our way into the future, what we have planned next. So next slide, please. So the energy management team has been busy at work here at the University of Michigan for many, many years. The goal of the team is to reduce energy consumption and therefore greenhouse gas emissions in our existing buildings. And we do that through a variety of activities, namely two major streams of work come to mind: energy conservation measures, known as ECMs. And these projects are pretty simple by definition. There's a capital investment into a building that results in energy reduction. Some examples are lighting upgrades to LED, advanced controls for lighting and HVAC within rooms across campus, advanced controls on HVAC systems, including air handlers and pumping systems, upgrading existing pumps with efficient pumps, window film installations, and a variety of others. Another stream of work is under our existing building commissioning umbrella, which includes operational improvements, building tune-ups, which are look at our building systems and find ways where we can identify issues or deficiencies and correct them, and then find efficiencies along the way to make improvements. And finally, our room side recommissioning, doing similar work at the room level, looking at thermostats and our air valves, reheat coils, perimeter heat, and making sure all those components that were working properly at one time, let's make sure they're still doing that and working towards the design intent. Next slide. So this work that we're doing, it couldn't be done without our partners across campus, including architecture, engineering, and construction, Marina's group, maintenance services, utilities, and then various roles throughout the schools and colleges. We work with these folks on a daily basis. This is where some of the ideas come from. This is how we make our ideas come to life in the buildings. The work in energy management began back in the early 1990s, almost 30 years ago, with the first energy engineering positions that were created. So it's been a long sort of tradition that there's a value in this work, that there's value seen in investing time and resources in this work to save energy and to reduce our carbon footprint on campus. And historically, our focus has been on general fund buildings. This is a kind of the funding path for our team. And the general fund includes all of our instructional facilities, our classroom buildings, our administrative offices, a lot of our research space, and performance venues. Next slide, please. So a good question to answer is, why would we focus on existing buildings? This chart is from the PCCN report that was presented early last year, and it shows that 99% of our scope 1 and 2 emissions here on campus are a result of our operation of our buildings. And the majority of those, of course, are here on the Ann Arbor campus. That includes all of our campus buildings, the hospital, athletics, student life, every building at the campus or that the university owns and leases. So this is a big, obviously, the lion's share of our footprint. So we heard earlier in the first half of this presentation about how new buildings and major renovations will address climate, or changing our approach to constructing buildings and renovating buildings so that we're consuming less energy and emitting less carbon. But for those buildings that don't have a deep renovation planned and that are going to be around for a long time, energy consumption will not improve without some kind of action. That's where our team comes in with our ECMs, in installing new technology where we find that to be appropriate, operational changes and strategies, and working with the users to find better ways to run our buildings. Next slide. This graph is showing over time what has been going on and what kind of an impact has this work had on campus. The line at the top of the graph is showing overall raw energy consumption for the Ann Arbor campus all the way back to 2006 through last fiscal year of 2021. And it shows, again, raw energy. So this is in BTUs. It's accounting for electricity, natural gas, and steam. And then the yellow bars are showing the growth of campus in building square footage. And since 2006, as many of you probably know, we've had an incredible amount of growth. Since 2006 to 2021, we've seen a 17% increase in building square footage. We have also seen energy maintain kind of a relatively flat trend line there. Now, granted, there is a little bit of a dip for the last 2 years because of COVID and the impacts that has had on our campus buildings and the occupancy. But we see the fact that we're able to keep things pretty steady in terms of energy consumption to be a very, very positive sign. And we've seen an energy density decrease over this time of nearly 30%. Next slide, please. So into the future, what's new? What's going to happen? This work that we're doing here on campus is going to expand out beyond the general fund and into the auxiliary units, including student life, Michigan medicine, and athletics on the Ann Arbor campus, as well as the Dearborn and Flint campuses. We're in the midst of designing and launching a revolving energy fund, or known as an REF. And this is a financial vehicle that is designed to help ramp up the work that we're doing. So this is available to all units, schools, and colleges across campus, again, including Dearborn and Flint. And the way it works is an energy conservation measure or an energy project is presented to the revolving energy fund, and it is funded as a project. And then through the savings that are realized by that project, it is repaid back into the revolving energy fund, which are then reinvested into campus again and again. To start, there's been a commitment for $25 million of seed funding over the first 5 years, with $5 million of projects launching this fiscal year. And the projects that will be included in this work are many of our traditional ECMs that I mentioned earlier. And we're in the midst of the design, as I said, of figuring out exactly how this process will work. But again, in the basic terms, these are capital investments that will result in carbon savings in our campus buildings. And with that, I will hand it back to Katrina. Thank you.
Great, thank you, Kevin, and all our other panelists. We will go ahead and launch our Q&A now. Keep the questions coming, and we've got a lot of them to answer. So first, I will briefly address one question that came into the chat, which is about what are Scope 1 and 2 emissions. We'll just go ahead and put that one out there. Scope 1 emissions are direct on-campus emissions, whereas Scope 2 are what we are attributed to us based on our purchased electricity and other energy. All right, so our first question, I will direct this to Marina. Very big picture question. Can we expect a paradigm shift with the new building standards?
Well, I think on that one, that's a good question. And some of the things that have been brought up when we talk about paradigm shift are the type of questions that have to go with fenestration on buildings, right? The type of buildings that we are building that you see on campus may look like have a lot of windows. And it's a good question. And the architects have a great challenge when it comes to meeting the requirements of the occupants and the building envelope, because people like light, and being able to enjoy the exterior while in a building, and some functions require it. So as an example, in the upcoming CCRB building, folks, when they're exercising, they want to be able to see the exterior. And in your apartment, you want windows. So the function drives the exterior, the design. But when you do it right, the exterior from an energy use standpoint and the needs of the users can both be accommodated at the same time. So some of the exteriors may also look deceiving. As an example, in the BSB building, if you had to guess the window to wall ratio in that building, you might be surprised because it has 2 large atriums, it has large windows, but the window to wall ratio is 31%. And it's misleading, right? It looks like it has a lot more glass than what it actually is. It's because you're not looking at all the facades of the building, right? If you look at the other areas, you don't see that many windows. So we pay close attention to this, because if we do not get the right balance, we have to make up the energy loss through more equipment to reduce energy consumption. And that means more for first cost. So it all ties together, and we also need to reduce our costs. As Lars mentioned, we have to look at the total picture. So we do pay very close attention to this. And as another example, in robotics, the percentage is higher on that building, but because of the atrium, and to accommodate that reduction in energy, we put in triple glass windows. It is a higher cost, but it does reduce the energy loss. So those are the type of things that we look at. And if we look at another example, CIT, again, it looks like a lot of windows, but in that one, the percentage is 25%, which is even below the prescriptive glass allowance by ASHRAE, which is 27%. So our teams we have put much more emphasis on things like that, on the envelope, and within the standards, we would require that kind of evaluation. Hopefully that covers the.
Thanks, Marina. Appreciate that. We have another question that we could hear from all of our panelists on. How about we start with Jen and then go to Lars? What are common misconceptions about carbon neutrality and the role that buildings play?
Also a very broad and an interesting question. I think part of the role of misconceptions, I think, has to do with our experience of buildings, as distinct from the factors within buildings that really drive things like emissions or energy consumption, and increasingly discussions about embodied energy in terms of the carbon footprint of what it takes to construct a building in the first place. And oftentimes these things, our experience of buildings are very direct in terms of natural daylight and the spatial components of buildings, which can have influences on emissions reductions. But a lot of the techniques in place that really gain us the emissions reductions, which Lars can speak more to, are systems-based or material selection-based, and not always directly experienced in our everyday occupation of the building. The more that we study these relationships between what factors drive CO2 emissions, the more we also see that sometimes there are unintuitive relationships, things that seem like they would reduce emissions more or less, that aren't so obvious when you really look at the complexity of all of the interrelations between the components. So this is why the multivariable associations of how parts and pieces add up to more than the individual components is an important part of the work too. And those are the kinds of evaluations that aren't necessarily so evident at first glance.
Yeah, I just want to agree in these. The thing is, it's really this holistic process, when you're only looking at one part of the building, like the building envelope, and you are going to ignore the HVAC systems, then it's not the right concept. You have to see everything as a holistic concept, which also includes the way how the electricity is produced. And so this kind of to find a holistic concept with, how much insulation do we need? Is it better to improve the amount of insulation, or is it better to use a more efficient heat pump, for example? Now, this kind of question is very important to analyze and to find a better solution for the future, for future buildings, including building renovation in this case. And embodied energy currently takes in the life cycle assessment just around 10 to 20%. But when we are going to improve the building envelope and the building standard in general, then the embodied energy is getting more and more important, because the operation, the CO2 emission for the operation gets less part of it for the entire life cycle assessment evaluation. So there's also another dimension which comes in play in the future to think about, including the circular economies and all these kind of things, which is very interesting to look at in the future.
Kevin, do you have anything to say on this topic about common misconceptions?
Yeah, I think I'll add that I think most people may be familiar with the carbon footprint of, let's say, a typical residential home. And when compared to our campus buildings, it's astounding how much energy our buildings use. And it's a variety of reasons why. There are building codes, there are ventilation requirements that we have to provide to every room based on type. The research and the clinical care that goes on in our campus buildings are incredibly energy dense, and so it's a necessity to use that energy, and it's not, we simply can't not use energy here. With what we do on campus, it doesn't support our mission. And so the delicate balance here is to identify ways where we can maintain our support of our missions across campus and use as little carbon as we can. And I'll encourage folks to visit the OCS webpage, where we do have an building energy page where you can look up any campus building that you're interested in and see the footprint per building to help give you a sense of the scale here.
And let's end with Marina. What are you thinking about the most common misconceptions about carbon neutrality and the role of buildings?
Well, as Lars and Jen mentioned, how everything has to work together to design the building, and the effort that the engineers and the architects put into making the right balance to reduce the energy. I think it's not as apparent, right? There is a lot of modeling that goes in, a lot of evaluations on which is the best mechanical system for the use. And even as Kevin mentioned, we work very hard in figuring out how can we reduce or push the user into accepting something potentially different. Like, you may find the building's a little colder now in the winter than they used to be 10 years ago, because we are changing the, and it's not, because the systems are not working, it's by design. We just need to be a little more tolerant, as you might be in your own home, right? You might have been recently, or in the last few years, you might be turning down the heat a little more than you used to. So those are the type of things that I think are not as visible to ones looking into our buildings.
Great, thank you. We've had a lot of questions come in, which is excellent. Just a heads up, we may not get to them all, but let's move to the next one. This was submitted by John Mursky, and I'll direct it to Marina, at least to start. When optimizing construction design based on costs versus carbon emissions, what costs are included? For example, the construction costs themselves, ongoing operational costs, social costs, embodied carbon, what's included when we're trying to optimize those costs?
Well, the cost includes the first cost, obviously, and then operations. And now, obviously, we are looking, that's where the whole effort is in the greenhouse gas, is to include what does it create as we evaluate these different options. And in the industry now, we're also looking at the embedded carbon. As Lars mentioned, there's been, from an industry standpoint, there's been a lot of effort in looking at that. So all those items come into consideration as we're looking at the individual ECMs, energy conservation measures.
Lars, did you want to add anything on that topic?
Just to add a little bit, we are also talking about the lifespan of materials, which is included in the life cycle cost, and life cycle assessment. Life cycle assessment is about the CO2 emission of materials, but also the CO2 emission for operation, right? So it's also important to look how long does material last. And sometimes, as you know, it is better to invest at the beginning a little bit more, because then you have less, you have to replace it at a later point of time. Yeah, just want to add this.
Yeah, thank you. Okay, so next question is about how the landscape has changed because of COVID and making better use of campus buildings, and a very related question about the ventilation demands that we've experienced because of COVID and how that balances with energy conservation. How about Kevin, could you address this question to start?
Yeah, sure. So we've seen a combination of two things happening throughout the pandemic. Obviously, occupancy is down. It has been down, slowly ramping back up, and that has influenced energy consumption in our buildings in terms of plug load and lights are on, things like that. At the same time, we've countered with an increase in ventilation where possible, and verification that our buildings are achieving the proper amount of ventilation as designed. So we've seen, I think, an overall reduction in energy consumption in our buildings across the board, but it's on a case-by-case basis whether or not the lack of occupants has been enough to overtake the increased ventilation.
And to the broader question of how is the landscape changing because of COVID and changing ways that people use buildings, any of our panelists have any thoughts on those?
Well, the use of buildings it could be a result of COVID, but it's also what was happening within the industry. There is more open space and sharing of space. So I don't know where this will be going, but we may see more of that coming from our users where they may not need as much space in the future as we have in the past.
Yeah, that's a good point. All right, another question that we have for you all is about the most critical changes that U of M must make when it comes to decarbonizing its building stock. Let's start with Kevin for that one.
So this is a great question, and it's a topic of discussion on our team and beyond on a regular basis. I think the default position is let's make our buildings as energy efficient as we can, looking just specifically at the building on its own. But it's really critical for us to think about how that building fits into the district energy. I know it was mentioned early on, this webinar is focused on buildings. Yet we can't move forward with plans of how we're transforming our buildings to a carbon neutral campus of the future without understanding more about what that campus looks like. So is geothermal a part of that? And I know that decisions that are being made today on these systems We're asking those very questions, and so we don't have that long-term game plan yet, but we're trying to be as strategic as possible with today's decisions in our buildings. And as time goes on and those long-term plans are set and in motion, it'll be a little bit easier to make those building level decisions.
I can add a little to that regarding geothermal, especially because that is one of the areas where, as Lars mentioned, is the source of the energy, right? Where are we getting our energy? And so we are currently incorporating geothermal in 3 projects, but they are standalone geothermal. So we're also looking at a energy-wide study for North Campus, picking up from the PCCN study and looking at what should the energy from a central standpoint be on North Campus, because that is much more efficient than doing standalone geothermals. So, but the ones we are designing right now will be made so that they can be connected within a future long-term type of installation. So there is a lot of work going on currently, in not just at the university, but from a state and country-wide, looking more into geothermal and other energy sources.
Yeah, while I think that geothermal heat pumps is a very good solution for our campus, for example. But I have to mention that even when the geothermal heat pump has the best efficiency between all these different electric systems, for example, but a little bit the problem with the geothermal heat pump is the relatively high investment costs, especially for private houses. So to look beyond the University of Michigan, to look, for example, at renovation projects here in Washtenaw County. So I personally think there might be also more cost-effective solutions besides the geothermal heat pump, where we can find a good solution between the upfront cost and the operation cost, and I know that DTE as a kind of provider has also the goal to reduce the CO2 emission for the electricity production. So this, once again, comes to this other kind of level where we can probably find a more, this comes a little bit to this affordability problem, which we are also going to target in general in our society. And while I'm a big fan of geothermal, but probably for private houses, there might be other solutions which I would propose in this case.
Thank you. So another big picture question. Let's start with Jen and hear from Lars from your perspective. What leaders or organizations or other examples should U of M look to as we work to decrease the carbon intensity of our building stock?
This is a great question because there is a tremendous amount of work happening both at the local level through the efforts at the City of Ann Arbor, at the national level, both through municipalities, in some cases state-led efforts, and a lot of work at the university level as well. One of the things our building standards team did was to look at building standards being developed and promoted by other universities in North America, including some just across the border in Canada. Toronto is one university that has some pretty aggressive standards that were influential in some of the approaches that we were moving towards within, if you think of our climate region. And then, of course, globally, as Lars mentioned, there's a tremendous amount of efforts happening beyond the immediate borders of North America. So it's hard to state specific efforts, but I think when you start to understand that there's just a tremendous volume of work happening on this field, One of the things that I think is exciting about that is that it potentially has the potential, as the work at University of Michigan that we're discussing today, to influence a faster adoption of state standards. So right now, U of M will be self-reinforcing these standards, but they're not standards that would affect new construction throughout the state. But these kinds of standards could lay the groundwork for the adoption of similar kinds of aggressive standards at the state level or neighboring states or beyond. And hopefully, being in conversation with the city of Ann Arbor as they move their efforts towards a kind of net zero community, and the university is looking to engage in that conversation and also be a leader, a model for others looking to do the work, that all of these bits and pieces will come together and make an easier pathway for everybody trying to make these efforts together.
Yeah, I think what I want to add is also, we know these days how to make a net zero building in each climate zone. So the technology is there, yeah. But the big question, and I see a big opportunity for University of Michigan in it, is how can we make it affordable? How can we make it more accessible for middle class and lower middle class families? Yeah, how can we make all these efforts more affordable, like affordable housing and so on, all these kind of questions. This might be a big contribution for University of Michigan to make an example, not just to make less CO2 emission, but also to make it affordable for the general society.
Thanks, Jen and Lars. So we're coming up close on our end here. We've got lots of great questions, many of which have a lot of technical details to them, which we love. There's a lot of stuff on this topic that is for all of us to learn more about as we keep going and the university keeps advancing in this arena. I'll ask all of our panelists to close by sharing, if you were to meet any member of the U of M community who is not particularly aware of these topics yet, or many of us are just learning about this stuff, what would you want them to understand about energy, buildings, and carbon neutrality work? Let's start with Kevin.
Well, in addition to what I said earlier, but just about helping frame the context of buildings, the energy that they consume, and the necessity of it, I think I would speak about the hope for the future, and that the technology, as Lars just pointed out, the technology is there. It's not the climate that we're in, we can still do this, and that there is proven technology around the world for us to achieve carbon neutrality. It's going to take a long time because it is such a big and complex campus with many buildings involved, but there's a lot of hope in the future.
Marina, how about you?
Well, I would say participate in the reduction, right? As a occupant of the buildings, be tolerant when we're asking to be a little colder or warmer, and be part of the solution, right? We're all trying to come up with ways to reduce energy consumption, and we can use everyone's help in doing that. So if there are great ideas, participate and help us. Thanks, Marina. How about you, Lars?
Yeah, I would ask, take the risk, take the opportunity, invest into research work, and most importantly, make an example. Make an example, because to test in a real environment is much more effective than just to work on our computers here doing the research work.
And Jen, what would you have as a takeaway for someone who is part of our community, and what about buildings, energy, and carbon neutrality?
I think I'll just reiterate some of what Marina was pointing out, which is that there is a very strong cultural component to everything that we're describing. And while it's true that the technology is available and in place, there also is a balance that is trying to be explored and discovered through design work and through the work that we're doing in envisioning what the future of our built environment looks like, both from a material perspective, from a scale perspective, how much do we need, how do we use these things, how do we behave in our buildings, because even though theoretically we can put in place renewables to kind of cover a wide range of energy demands, which seemingly makes it look as though the energy demand is no longer important. Those technologies that we're utilizing are energy consumers as well. When we look at the larger picture, when we think about life cycle and where all those materials are coming from extraction all the way through. So it really is a very intricate puzzle that really does reflect a lot of cultural and societal values. And so there is a great deal of participatory power that we all have in staying educated and staying aware and participatory in the way that this design work takes shape in the next decade and beyond.
That is an excellent point, Jen. And there's a lot of, as Kevin said, hope for our future. And it's a cultural shift we can all get on board with. It's a very exciting time. Thank you to all of our panelists for this excellent conversation today, and to our audience for being here and for all of your excellent questions. I'm just sorry we couldn't answer all of them today. We'll have to have future events of this nature as these sorts of efforts progress. Please do visit planetblue.umich.edu/carbon neutrality for updates, and you can submit any input you have as we continue to progress on our carbon neutrality goals. So thank you all again, and have a wonderful afternoon.
Thank you.
Thank you.
Thank you, everyone.
Thanks, everyone.